Have you ever stared at a pot of boiling water, waiting for your potatoes, rice, or tough cuts of meat to finally cook? It feels like it takes forever. But then, you take those exact same hard ingredients, lock them inside a heavy metal pot with a strange little weight on top, and suddenly, magic! Dinner is ready in a fraction of the time. Welcome back to Simple Things Surprising Histories. Today, we're looking at a kitchen superhero sitting right on your stove, the pressure cooker. How exactly does this loud, hissing pot cook food up to 70% faster than normal? To understand how it works, we have to travel back to the year 1679. Meet Denis Papin, a French physicist with a very specific problem. He wanted to find a way to extract fat from animal bones. Normal boiling just wasn't cutting it. So Papin designed a tightly sealed iron pot that trapped hot steam inside. He called it the steam digester. When he presented it to the Royal Society in London, it was an absolute sensation. He cooked a meal for the scientists using his new invention, and they were blown away by how incredibly tender the food was. But Papin's early versions had a tiny, terrifying flaw. They occasionally exploded. To fix this, he invented the safety valve, a brilliant little addition that released excess pressure before things got dangerous. 300 years later, that same basic design is sitting right in your kitchen. But what exactly was happening inside Papin's iron pot, and what is happening inside yours today? It all comes down to the relationship between water and pressure. In a normal open pot, water boils at 100 degrees Celsius or 212 degrees Fahrenheit. Once water hits that temperature, it turns into steam and evaporates away. No matter how high you turn up the heat on your stove, the water will never get hotter than 100 degrees. That is the absolute speed limit for your cooking. But a pressure cooker changes the laws of nature. When you lock the lid, the steam has nowhere to go. As the pot heats up, more and more steam is produced, crowding the empty space inside. This creates an enormous amount of pressure, usually about 15 pounds per square inch above normal atmospheric pressure. Under this intense, heavy pressure, the boiling point of water is forced upward. Instead of boiling at 100 degrees, the water now has to reach around 120 degrees Celsius, nearly 250 degrees Fahrenheit, before it can turn to steam. That extra 20 degrees is the ultimate secret to the speed. In the world of chemistry, there is a general rule that every 10 degrees rise in temperature cuts the cooking time in half. So at 120 degrees, your food is cooking significantly faster. Not only that, but the intense high pressure physically forces the superheated liquid deep into the food. This rapidly breaks down tough starches and softens the rigid fibers in meats, hydrating hard beans in record time. It isn't magic, it is simply thermodynamics at work. So, the next time you hear that familiar hissing sound coming from your kitchen, you'll know you aren't just making dinner, you're conducting a high-pressure physics experiment, carrying on the legacy of a 17th century French inventor. If you enjoyed discovering the hidden science and history behind the pressure cooker, make sure to hit that like button. Share this video with a fellow home chef and subscribe to Simple Things Surprising Histories for more fascinating stories about the everyday objects around us. Until next time, keep cooking and stay curious.